Our tutorial, Treynor Ratio Performance Metric. Portfolio performance metrics consist of portfolio expected or realized risk premium by unit of risk. This topic is part of investment portfolio analysis with our course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please read full tutorial disclaimer at the end of this video. Treynor ratio consists of portfolio expected or realized risk premium by unit of systematic market risk. For full reference, I recommend that you read Jack Treynor, How to Rate Management Investment Funds, published by Harvard Business Review in 1965. As a formula, we have the ex-ante or expected portfolio returns Treynor ratio, which is equal to, and within the numerator, we have the expected risk premium as the difference between portfolio returns minus the risk-free rate of return, which is then divided by the expected portfolio market beta. And then we have the ex-post or realized portfolio returns Treynor ratio, which is equal to, and within the numerator, we have the portfolio returns mean minus the risk-free rate of return mean, and that result is then divided by the portfolio market beta. The portfolio market beta in turn is equal to, and within the numerator, we have the covariance between the portfolio returns and the market returns, which are then divided by the variance of the market returns. Within this video tutorial, we'll only be studying the ex-post or realized Treynor ratio. If the risk-free rate of return is not constant through time, then the portfolio returns Treynor ratio is equal to, and within the numerator, we have the portfolio returns mean minus the risk-free rate of return mean, and that result is then divided by the portfolio market beta. Because of having that non-constant risk-free rate of return through time, then the portfolio market beta is equal to, and within the numerator, we have the covariance between the risk premium and the market risk premium. The risk premium as the difference between portfolio returns minus the risk-free rate of return, and the market risk premium as the difference between market returns minus the risk-free rate of return. That result is then divided by the variance of the market risk premium, again market risk premium as the difference between market returns minus risk-free rate of return. On the other hand, if the risk-free rate of return is constant through time, then the portfolio returns Treynor ratio is equal to, and within the numerator we have the portfolio returns mean minus that constant risk-free rate of return, which is then divided by the portfolio market beta. For the calculation of this portfolio market beta, we use the same formula as in our previous slide. And last, if for simplicity purposes we assume a 0% risk-free rate, then the portfolio returns Treynor ratio is equal to, and then within the numerator we have the portfolio returns mean, which are then divided by the portfolio market beta, again this portfolio market beta calculated using the formula from previous slide. Perfect. So let's go into RStudio so that we can study Treynor ratio with greater detail. Excellent. So here we are within RStudio. In this tutorial, we'll be working within our tutorial Treynor ratio performance metric code file. So the first step within the tutorial is to load its packages. This is done with the library function, and within this tutorial, we'll be using performance analytics. So here we select the code line, then we click run or Ctrl Enter on the keyboard, which is equivalent. The following step within the tutorial is to create Treynor ratio performance metric data. For this, we are going to create an object named returns, which is going to be equal to read.csv, and within it we have the name of the data file, Treynor ratio performance metric data, as a plain text file with .csv or comma separated values and stored within the working directory, comma header equals to true. So we select that code line there, then we click run or Ctrl Enter on the keyboard, which is equivalent, and that creates a return object within the global environment as a data frame. So we click on the spreadsheet kind of icon, and this opens the data for us. As we can see here, we have 3 columns of data. First of these dates with a monthly frequency from the beginning of 2007 all the way to the end of 2016, therefore 10 years of data. Then we have SPY column. SPY corresponds to the ETF investment vehicle, which intends to replicate the Standard & Poor's 500 index. And what we have here is its corresponding adjusted close prices which were adjusted for dividends and splits, and their corresponding monthly arithmetic returns. And then we have MKT, that corresponds to the market portfolio, and again we have that market portfolio monthly arithmetic returns. So back into the code file, the following step is we are going to convert that data frame into an XTS, which we do at the following row. So we're going to overwrite returns, and it's going to be equal to an XTS or extensible time series. And what we do is we select from returns columns 2 and 3 with those corresponding monthly arithmetic returns, comma, order by equals as date returns column 1 with the corresponding dates. So we again select the code line, and then we click run or Ctrl enter on the keyboard, which is equivalent. So notice that now returns object became an XTS or extensible time series, and if we reopen the object, we see exactly the same data, but now the dates became its index. So back into the code file, the following step is now that we have the data ready, we're going to perform Treynor ratio performance metric calculation. So first we are going to perform it using this corresponding code line in which we have mean of returns, and we are going to do the calculation of the monthly Treynor ratio for SPY, monthly arithmetic returns, and for simplicity purposes we're going to be assuming a 0% risk-free rate. So we have within the numerator of the calculation mean of returns, and with the dollar sign we select SPY monthly arithmetic returns, which are then divided by, and we're going to be using the function CAPM or capital asset pricing model dot beta, and within parentheses we have RA, the asset returns, in this case returns again we select with the dollar sign SPY corresponding monthly arithmetic returns, comma RB, that's the benchmark, and for the benchmark we are using, as we can see here equals to returns, and with the dollar sign we are selecting with MKT the market portfolio returns. And as mentioned previously, for simplicity purposes, comma, we're assuming a risk-free rate of return of 0%. So here we select the code line, then we click run or Ctrl enter on the keyboard, which is equivalent, and notice here the result being printed. Again, this is the monthly Treynor ratio calculation for SPY monthly arithmetic returns, assuming a 0% risk-free rate for simplicity purposes. So at the following row, we're going to do the calculation again, the same calculation, monthly Treynor ratio for SPY monthly arithmetic returns, assuming a 0% risk-free rate for simplicity purposes. Therefore, within the numerator, we have the mean of returns, and we select with the dollar sign SPY monthly arithmetic returns. And then we're going to divide that result, and now we're going to calculate the corresponding beta with the function and formulas we saw within the slides. So here we have COV, that's the covariance between returns, and with dollar sign we select SPY, comma, returns, with dollar sign we select MKT for the market portfolio returns. And we're going to divide that result, as we can see here, by the variance of returns, and with the dollar sign we select MKT or the market portfolio returns. So we select that code line here, and we click run or Ctrl enter on the keyboard, which is equivalent. So notice here that the result is being printed, and we have exactly the same result as the one we saw above. So here we have two forms of calculating that monthly Treynor ratio for SPY monthly arithmetic returns and assuming a 0% risk-free rate for simplicity purposes. Perfect. So now that we finished studying Treynor ratio performance metric, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finished this tutorial. Thank you for watching.